look at the periodic table, you must be surprised or confused. You may feel, how will I learn the whole periodic table, so many elements, and what is the use of this table? Have you seen a pile of things in your storeroom? You must have seen. And how you feel when things are scattered here and there? Let me give you an example. See these bricks. They are all scattered. An architect designs, a mason organizes these bricks to make astonishing buildings or houses for us. They work to give us a wonderful place to live in called home. In the same manner, we need to organize things in our home so that we can use them properly and our house looks beautiful, isn't it? In the same manner, scientists felt the need to organize or arrange the elements with similar properties in groups and periods and form a complete periodic table for the purpose of convenience. Dmitry Mendeleev is considered as the inventor of modern periodic table. Periodic table can be divided into 7 periods and 18 groups. The first 2 consecutive groups are called alkalis and alkaline earth metals.
The properties of these groups are different from each other.
Then comes the transition elements, which are grouped in the middle of the periodic table from group 3 to 12. On the extreme right, there are halogens or highly electronegative elements that needs only 1 electron to complete the octet. After that, noble gases are grouped in group 18.
Now let us talk about the first and second group elements, alkalis and alkaline earth metals. The first element of the group is hydrogen with atomic number 1. Hydrogen has exceptional properties that will be discussed in a separate video. Now we will start with lithium. The electronic configuration of lithium is 2 and 1. Lithium has a tendency to lose this extra electron to become stable. In the same manner, sodium and potassium have electronic configuration 281 and 2881 respectively. Due to this 1 electron, they are grouped under alkalis or first group. They are electropositive and they react with water to form alkalis or strong bases. Now comes the second group elements, alkaline earth metals. The first is beryllium, second is magnesium, third is calcium. The electronic configuration, as you can see, is 2 and 2 for beryllium, 282 for magnesium, and for calcium it is 2882. They are harder and less reactive than alkali metals. In the outermost shell, there are 2 electrons. They have the tendency to lose the last 2 electrons to become stable.
Transition elements are grouped in the middle of the periodic table, and transition means change. So metals are grouped on the left hand side of the periodic table in the first and the second group, that are alkalis and alkaline earth metals. And non-metals are grouped on the right hand side of the periodic table. The transition elements or transition metals are grouped in the middle. That means a change. The properties of these elements or these metals are different from alkaline earth metals and alkalis. These have high melting points and densities. Due to these and other properties, they are very useful in day-to-day life. Like copper is used in water pipes as it does not react with water at room temperature, and it can be beaten into different shapes. In the same manner, iron, cobalt, nickel and other metals are commonly seen in everyday process. We will study transition metals separately in another video. There you will be able to see how the properties of these metals are different from those of the first and second group element. Now comes halogens. These elements are grouped under group 17 or 7th A. They are called salt producer because they react with metals to form salt.
Example is chlorine,
which needs 1 electron to complete the octet. It reacts with sodium, that is Na, to form NaCl, that is the common salt, sodium chloride. Another example is CuCl2, copper chloride. They are non-metals, highly electronegative and very reactive. If consumed by biological or living organisms in sufficient quantities, they can prove lethal or toxic. Fluorine is one of the most reactive elements. All of the halogens exist as diatomic molecules, as chlorine exists as Cl2, bromine as Br2, iodine as I2. These are all diatomic molecules. We'll study each of them separately. Now comes the noble gases. Do you recognize the name noble? Yes, you guessed it right. They are actually noble as they are chemically inert gases. Their electronic configuration is complete, so they do not need to react with other elements. So they are called noble. Now comes lanthanides and actinides. These elements are called inert transition elements. Lanthanides or lanthanoids start from 57 to 71. Actinides or actinoids start from atomic number 89 to 103. 10th graders, you must have studied electronic configuration in 9th standard.
Periodic table and electronic configuration are the basis of chemistry. These are the fundamental concepts. Once they are clear, you will never face any difficulty in understanding advanced chemistry concepts. To watch subsequent videos, stay tuned by subscribing the channel, and if you want to join Scholar, which is a child-centered education system and activity-based learning, which makes the child understand the basics and revise the concepts that are retained forever. You can register for free and book a 3-day trial session. Goodbye for now, and we will study periodic table in detail in the coming episodes.